Okay, so we have Q in. We're working on getting the network per cycle. And we said that's Q in minus Q out. So we need to work on Q out. And the heat's rejected from process 4 to 1, which is constant volume. So if we go to process 4-1, looks like a rigid tank, constant volume process. Q out, we find negative Q out is going to be the change in energy of the system. Final state is 1, initial state is 4. So if we solve for Q out, mass times U4 minus U1. We found the mass already. It was that's 6.6 grams. We found U1 earlier. All we need is U4. U4 depends on T4, and so we can go. We can use isentropic process, ideal gas, variable specific heat from state 3 to 4, because 3 to 4 is isentropic. And so if that's the case, we can write VR4 over VR3 is V4 over V3. Solve it for VR4. Alright, so we know T3, so we can look up VR3. We don't know many of the other things. We don't know V4, V3, but we can get to those because we know that the compression ratio was 15, and it's V1 over V2. We also know that the cutoff ratio was 2.4, and it's V3 over V2. And we know that V1 is constant volume heat rejection, so V1 is V4. So I can manipulate these things to make it look like V4 over V3. So I'll put V4 here. I can solve these two things for V2 to get rid of V2. So I'll put V2, and then I'll divide the two things. I'll set them equal to one another. So V2 is equal to V4 over 15. And V2 is also equal to V3 over 2.4. And then I'll rearrange it to look like that, 4 over 3. So I'll divide this, 15 will go up there. Over 2.4. There we go. We've got this ratio, then multiply by VR3, then we'll have T4, we'll have U4, and we'll be set. So let's get that. We can go ahead and get this number.